All right, this video is going to kind of be a weird left turn for us for a second. We're going to talk about adding, subtracting, and multiplying polynomials. This is actually sections 6.1 and 6.2. So I'm going to show you or just remind you of some quick vocabulary, and we're going to do some quick examples, and then we'll be done. All right, so polynomial is just anything that has multiple terms. A monomial is something with one term. So identifying monomials, just for the example or sake of your notes, if you want to write these down, x to the third is a monomial. This right here, a squared bc to the 12th is a monomial. What it is written here in between is called a polynomial. If we're going to write polynomials in standard form, that means to go from the highest exponent down to the lowest. So we just count down. So for example, this one would be negative 5y to the third, because third is the highest exponent, and then plus 3y squared. All right, so that's 3, 2, 1, which is just plus y, and then 0, an exponent of 0 is plus 10 because there's no exponent or variable there on that. And then this last 76, this is a constant, which is just a number that is by itself, not using a variable. So those are your different terms there. All right, if we talk about degree, degree has to do with the exponents, and it's the sum of the exponents themselves. So for instance, this first monomial has a degree of 3 because that's x to the third. This next one is going to have a degree of, let's see, 15. All right, there are 2 a's there, 1 b, and 12 c's. So altogether, that is 15, a count of 15 exponents. This 76 has no variables with exponents, so that's going to be 0 because there are 0 variables there. If we talk about terms, the number of terms that you have in each, terms in a polynomial are each of the separate pieces. So for instance, this has 4 terms in it. All right, identify the coefficient. So coefficient is the number in the front, which we'll use a lot here coming up pretty quickly. So the coefficient of y is just 1, right? That's like 1y. Coefficient of 3y squared is 3, and negative 5y to the third is negative 5. And then the degree of each, we already talked about that. So writing in standard form, again, I said, is just to rearrange it so it's from highest to lowest. So make sure you have some examples of all of those vocabulary words in your notes. All right, so there are 3 operations you already know about polynomials. They are addition, subtraction, and multiplication, and I am just here to remind you about how all of those work. So your book, you can see here adding polynomials. Your book shows you a few different options. To me, I think that's pretty complicated. You all know how to do this, I think, even if I didn't show you anything. So remember, parentheses tell you generally to distribute. This is just saying, obviously, there's a 1 here to distribute, which is not going to change anything on the first one. 1 on the second one, not going to change anything there. So I'm just combining like terms. And because I want my answers, almost always you're going to want your answers to be in standard form. So because of that, I'm going to start with the highest exponent and just kind of group and count my way down. So the first one I see, the highest is this to the 7th. And there's nothing to combine that with, so that's negative 9x to the 7th. And when you've used it, you can kind of check it off if you want. I don't see anything to the 6th, anything to the 5th. I do have something to the 4th, so that's going to be plus 17x to the 4th. To the 3rd, I've got 2 things to the 3rd, a negative 2x to the 3rd and an 11x to the 3rd. That's going to give me plus 9x to the 3rd. Remember, exponents don't change when we combine like terms. Squared, I've got a positive 8x squared and a negative 8x squared, which are actually going to cancel each other out, so I'm going to use both of those. X to the 1, so that's anything that just has an x, and I don't see anything like that. And then x to the 0, so that's going to give me this plus 4 plus 12, which is going to be plus 16. All right, so there is my addition of polynomials. Let's look at a subtraction example. So subtraction, very, very similar. The only thing I want to show you in subtraction is that it's kind of like, you think about it like you've got a negative here distributing on this second set. So if I distribute that negative, it's going to change the signs. I'm going to end up with a plus 2x to the 5th and a minus 9x squared. To be honest with you, I think if you'll at least rewrite that part, you'll be less likely to make sign errors when you're combining like terms. So again, I'm going to count down. 5 looks like the highest exponent, so I've got a -8 and a +2. That's -6 x to the 5th. I don't have anything to the 4th. I have a 3rd, so +7x to the 3rd. Squared, I have a 20x squared minus 9x squared. That's going to be +11x squared. I do have an x, so +13x. And then I don't have anything with no x's, so there is my final polynomial for subtraction. All right, and the last thing to remind you of is multiplying with polynomials. So remember, when you multiply, you're going to be distributing, and you just distribute as many things as you have. So for instance, on this one, I'm going to have an x that distributes to everything on that second parenthesis. So that's going to be 3x. Remember, when you multiply, exponents are going to change, so -24x squared minus 4x to the 3rd. So notice that all of the variables, the exponents rather, changed on all of those. And then we're going to distribute this other term, which is going to be a -6 that's distributing, again, to everything in that second set of parentheses. So now we're going to have -18 plus 48x plus 24x squared. So make sure you carry that negative with it. And now we're just going to simplify like we did just a minute ago, combine like terms. And again, I like to do standard form, so I'm going to just count down. So that's -4x to the 3rd. Let's see, the 24x squareds are going to cancel each other out. I have a 48x and a 3x, so that's going to be +51x. And then -18. And that's how we multiply. All right, now the only other thing you might ask to be able to, be asked to do is to verify that some identity works. All right, so what that means is if you see those instructions, it's saying show that this is true. So it's basically saying if you multiply this out, you should get this answer. So, okay, you shouldn't be able to get this wrong, but you're just trying to show the work to prove that that's the case. So if I do that, a times a squared is a to the 3rd, all right, plus a squared b, right? A times ab is a squared b, plus ab squared, if I distribute at the end. All right, now I'm going to distribute this -b. And one thing, if you're ever distributing multiple variables, I still like to keep them in alphabetical order, but just make sure you keep the appropriate exponents with the appropriate variables. So -b times a squared is going to be minus a squared b. So notice that that is like -ba squared. I'm just going to put the a part first for combining purposes. All right, then I'm going to distribute again. That's going to be minus ab squared minus b to the 3rd. And now, again, we're just trying to show that this is true. And since we have a and b, there's not really a standard form here, so we just want to combine any like terms that we can. So a to the 3rd, that's the only a with an exponent 3 that's by itself, so that's going to give me a to the 3rd. All right, and then notice that I have quite a few that look the same. I've got a squared b, ab squared, -a squared b, and -ab squared. I can only combine ones that have the exact same exponent on the same variables. So the ones that I'm going to see that go together, a squared b and -ab squared, those can be combined. They are actually going to cancel each other out because one's positive and one's negative. And then I have ab squared and -ab squared. Those also end up canceling each other out. And so the only thing I have left there is this minus b to the 3rd. And that actually does verify what I wanted to get because they told me the answer and I got exactly what they said. So if you have all those written down, you should be good for tomorrow.